Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about what is superstructures. What is superstructures? The portion above the ground level and below the ground floor level is known as a plinth. The portion above the ground floor level is known as superstructure. It includes columns, walls, beams, floors, roofs, doors, windows, lintels, staircases, etc. The superstructure is designed to carry various load acting on the structure, such as dead load, live load, wind load etc., which are then transmitted to the underlying soil via the substructure. Each component of superstructure serves a specific purpose. However, the most common function served by all components is providing privacy, safety to the occupants. Wall and roof offer protection from the surrounding, doors allow entry and provide safety, windows provide necessary sunlight and fresh air, and floor give alluvial surface to live and protection from beneath. Types of superstructures. On this basis, there are two types. Load-bearing structures. Framed structures. What is load-bearing structures? In this type of structure, the load in the structure is moved vertically downward through walls. Loads from roof and floors get moved to wall, and then the wall must transfer these loads as well as self-weight. Such constructions are used in residential buildings in which the dimension of rooms is less. Residential buildings up to ground plus 2 floors can be built economically with such structures. This type of construction is suitable and economical up to 2 stories, though 4 stories can be constructed. As the wall footing directly rests on hard strata, this type of constructions adopted where hard strata are available at shallower depth. The speed of construction is less. If the number of stories is increased, the thickness of the walls increases considerably. This not only reduces the carpet area but even increases the cost. It is a structural system where loads of buildings, i.e. weight of building itself plus the live loads, get transferred to the ground through walls. Walls bear a load of roofs, floor and of course self-weight. In contrast, most construction today is not load-bearing masonry but frame structures of light but strong materials that support floor slabs and have very thin and light internal and external walls. In load-bearing structural system, external and internal walls serve as a structural element as well as the purpose of the enclosure for protection from weather, i.e. rain, sound, heat, fire, etc. What are framed structures? In this type of structures, a framework of columns, beams, and floors is built first. Then the walls are built to partition the living area. The walls are subjected to self-weight only. This type of superstructures is needed when a number of stories in a building are more and also when larger areas must be covered free from walls. Columns transmit the load to the foundation, which rests on a hard soil below the grounds. Walls do not carry load except their self-weight, which are transferred to beams on which they are supported. In comparison with load-bearing structured, they have more carpet area is available. The frame can be constructed using RCC for the residential and commercial complex. The speed of the construction is fast as compared to load-bearing structure. It can be constructed on any type of soil by using pile or raft foundation. They have good earthquake resistance. Load-bearing vs framed structures. SR No. Load-bearing structure. Framed structure. 1. Cost is less. Cost is more. 2. Suitable up to 3 stories. Suitable for any number of stories. 3. Walls are thicker and hence floor area is reduced. Walls are thinner and hence more floor area available for use. 4. Slow construction. Speedy construction. 5. Not possible to alter the position of walls after the construction. Position of walls may be changed whenever necessary. SR No. Load-bearing structure. Framed structure. 6. Resistance to earthquake is poor. Resistance to earthquake forces is good. 7. Taken deep into the subsoil foundation. Only column are taken deep into subsoil and provided with foundation footing. 8. Load-bearing structure type of construction does not favor too many openings for windows, doors, ventilation etc. in the ground floor as required for showroom etc., as the load-bearing length of wall is considerably reduced. The space between column can remains as open space as the case with multi-storied residential flats where the ground floor is left with no walls for easy parking of vehicle. SR No. Load-bearing structure. Framed structure. 9. In case of multi-storied buildings, the room area is reduced as we go down due to thicker walls. Thickness of wall remains uniform, therefore the carpet area in any floor remains the same. 10. This construction more labor-intensive. This construction less labor-intensive, but it needs different skills. 11. Limitations for providing openings in walls, which will affect the light end. Large openings in walls are possible. SR No. Load-bearing structure. Framed structure. 12. Load-bearing structures can be constructed without expensive plant and machines as compared to a framed structure. Framed structures require expensive plant and machines to construct. 13. Walls have to be built first as they support the slab roof, and hence all walls have to be built simultaneously, which is time-consuming. Generally RC framed structures constructed first and the external as well as partition walls are constructed later, hence speed is more. 14. In case of a load-bearing structure, large span areas are not possible. Limitation of span, i.e. room sizes. In case of a framed structure, large span areas are possible. No limitation of span, i.e. room sizes. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.